You ready? Okay, this is lecture number 2. It's spanning slabs. It will be part of the next test, so I'm going to go over the material for the test that you'll be taking shortly. It's posted on Canvas. Like to make sure you know what you're going to be tested over. We've gone over it once, but once again, we've got the test 2. That will be the beams. I think I drew them on the board before. The 3 beams are balance section, too big, too small, takes care of the rectangular sections. We've got the T-beam, which uses the beam itself and part of the slab to make the T. And we've got the last one, which is the first lecture of the series since we've been off, which is stirrups. So those are the topics that are going to be on the test. The test will be given via Canvas. You'll be able to go on Canvas and grab a hold of the test. And if I've got my test right, it's the 31st of this month, which will be a week from today, actually. Today being, actually it's a week, this coming Tuesday. So not today, but a week from today. I'm doing this on Tuesday morning. So if you take a look at those, there are 5 different possibilities. A balance section, too big, too small, T, and stirrups. So I would guess that you're going to have 5 questions or 5 problems on the test. The problems will be open book, open notes. And the test will be given on a time module, so the test will be available to you on Tuesday morning at 8 o'clock a.m. Okay. I will be collecting them. I'll give you a little more time than normal. I'll be collecting them at 9:45 a.m. The collection device will be Canvas, so you'll get the test on Canvas and you'll send it back to me via Canvas. Of course, it'll have a time attached to it, so please just make sure you have it in before 9:45. I'll grade them, and then we'll review them, and I'll most likely review them via a answer sheet, a key, and then talk about it a little bit on the next video after the test and make sure you understand it, and then we'll go on to the next unit. And what we're starting today is the beginning of the next unit. So the next unit is going to start with simple slabs. So we've got the following for test number 3. Test number 3 material will be 1, simple slabs. We're going to do that today. 2 is going to be, and that finishes up chapter 14. In addition to the simple slabs, I'm going to have development length. And I'll do that at the end of the unit. Okay, so we got simple slabs, we've got continuous slabs. That's chapter 14. And then we've got concrete columns. And that's chapter 15. And then we've got development length. And that is chapter 13.7, I believe. And we are in chapter 13.5 today. So it's simple slabs. A simple slab is just like a simple beam. The slab spans between 2 fixed supports. So if I've got a wall here and a wall over here, and I want to put a concrete deck over the top of it, now the concrete deck has supports on each wall. It's broke, there's a cold joint or an end of the slab at each side, so it acts as a simple beam. So that's what we're going to be talking about today. So we'll get simple slabs now, we'll have the test. The test then will be given this coming Tuesday, and then finish that off, we'll move into continuous slabs, which takes a little bit of time. This is a quick hitter, it's all tables, and then development length is a table also. And then we'll have our next test, and the way it looks, if my schedule has any credence at all, the next test will be somewhere right around the middle of April. And that'll take care of test number 3. Okay, so simple slabs. In the Files tab of Canvas, I put in this morning a handout, and the handout is one that has spanning slabs, one-way slab designed using beam theory with a width of 1 foot. So it should have on the top, Chapter 13, Problem Solving Guide, Spring 2020. So as you're going through this video, it would probably behoove you to grab a hold of this sheet, print it out, and follow it as we go through. Okay, we've got simple slabs. So I've got a couple walls. The slab is going to be poured over the top of those walls. The slab is going to have some length and a span width. And the span width typically on a single or a simple one-way slab is relatively short compared to the length. Typically in the engineering side of it, we limit the span width to 1/2 or greater than the span length. That's why they call it a one-way slab. So a one-way slab has not much to do with the direction you travel. All it has to do with is that the width is much shorter than the length, and that's typically twice. So anytime the length gets bigger than twice the width, we consider it a one-way slab. That means that the main steel is going to support it, going the width rather than the length. So now my main steel is going to run this way. It's going to go from side to side. On a two-way slab, it's more square, and we would run main steel both directions. We're not going to address that in this course. All we're going to worry about is the fact that it's a width that is much shorter than the length, classified as a one-way slab. Reinforcing steel main will go across the span, and then the other way will be, you will have steel going this way also, but that is not going to carry load. That carries elements. So this is called temperature steel. Okay, this temperature steel is mandated by code. It takes care of stress cracks caused by change in temperature or shrinkage. Some people call it shrinkage steel. So temperature or shrinkage steel will go in the opposite direction. So if you heard what I just said, spanning slabs, one-way slab designed using beam theory with a 1 foot width. So all we're going to do is design 1 foot of this slab, and then every other foot is exactly the same. So I'm going to take and I'm going to grab myself 1 foot. I'm going to take 1 foot, 12-inch strip, and I'm going to design that 12-inch strip. So that's the 12-inch or 1 foot strip I'm going to design. So if I take this 1 foot strip and I put a cross section through it, and I draw it, the slab is going to be 12 inches wide. So my strip is 12 inches. So B is going to be 12 inches. So for this particular unit, designing a slab B will always be 12 inches. Okay, then you'll see reinforcing steel going this way, and you'll see reinforcing steel going this way. Okay, if you look at that steel, I hope you can see that the steel in the blue is our main steel. The steel in the red is our temperature steel. Therefore, if you look at my picture, I'm going to do it with colors so that it matches that, okay? If I drew that section through there, you would see a blue dot and a red line. So the blue dots are going here, and the red line will be going there. So I've got main steel going the width. I've got the temperature steel going the length, and it ends up that I've got to design these guys, and these are going to be at some pitch. You can see I've got them drawn kind of apart. So when we get done, both of these are going to have a bar size at some pitch. So that's going to have something like a number 5 at 12 inches. This is going to be the same thing. A size and a pitch. Okay? So our job is to figure out 3 things. 1, the thickness of the slab. This is the thickness of the slab. Okay, like any other problem we've had, the thickness is not our determining metric. Our determining metric is the distance D, which is the effective depth, and that is from the top of the slab to the middle of the main reinforcement steel. So main reinforcement steel, you see how I put it on the bottom? I put it on the bottom because that increases D. We have to have cover. Of course, there's going to be cover there. We've got to have cover, so if I can get it lower, that main steel, that means that the capacity of the cross-section increases in strength. So D and T are directly related. We'll do that in a second. And we need to design T, thickness. That is normally designed based on deflection and then checked. So we have a table. And we'll go through that table in a second. It is at the back of chapter 13. And if you want to look at where that physically is, that table is right after development length. And the table we'll be using is table 1312 on page 478. Table 1312 on page 478. So that's going to be our initial, find T. We're going to check it, make sure everything works. If it works, then we're going to determine how much steel we need for bending. That's this guy. And the next thing we're going to do is determine how much steel we need for shrinkage or temperature. And that's a code-driven percentage. That's a simple one. It will determine that. So remember, 1 foot width. The width goes across the short dimension, the span. The length is not relevant. Once it hits over twice the width, it can go on forever. And this design is exactly the same. So we got a one-way slab. One way, not the direction. It's the direction of the main steel. The main steel is going one way. So this is not main steel. The red bars are not main steel. They're temperature steel. Okay, so I'm going to leave this little picture over here. Remember, B is always 12. D is directly related to T. So if I take a look at this cross section and I take a look at the requirements, and if you go through the requirements, it's going to tell you that the cover for a slab is 3/4 of an inch. So if I looked at this and I looked at the difference between T and D, T is the thickness of the slab. There's the main bar right there. Okay, so D is the dimension from the top of the slab to the center of the bar. So what do I have to do to get D if I know T? It looks like I've got to subtract the cover and subtract half a bar diameter. So all you got to do is take the bar diameter, divide it by 2, add the cover to it, and the cover in our case, we just said, was 3/4 of an inch for slabs. Add the cover to half the bar diameter, subtract it from T, and I have D. So that'll take care of that problem. So let's go about starting. We're going to start out by defining T, determine the dimension based on this table, and then we're going to work our way through the problem using the guide I gave you, and by the time we get to the end, hopefully you've got the concepts down. Okay, you guys are going to be doing 13.5B on Canvas, okay? I'm going to do 13.5A. So if you go to your book and look up problem 13.5A, we're going to follow that problem through using the handout.